Okay. I'm sorry that this is part 2 of angles of triangles, because in the last video the recording stopped abruptly, so I want to go over just a little bit of the top part. Some of it you haven't seen before because I was writing and it wasn't recording, and I can't erase it because it's pen. That's what I get for doing math in pen. But the third angle theorem does state that if two angles of one triangle are congruent to two angles of another triangle, so angle L and R are congruent, angle M and S are congruent, then the third pair of angles, angle N and angle T, are also congruent. So I went ahead and I gave some just kind of made up measurements. I do know that angle L should be larger than angle M, but I didn't make it that way, and it's okay for the purposes of what we're doing today. If angles L and R are congruent and L is 50 degrees, then the measure of angle R is also 50 degrees. Angle M and S are congruent, so if the measure of angle M is 51 degrees, then the measure of angle S is 51 degrees. And now I'd like to show to you why angles N and T are congruent to each other. So by the triangle sum theorem, the sum of the interior angles of a triangle should equal 180. So 50 plus 51 is 101, and if I add this variable x to it, representing the measure of angle N, then I should get 180 degrees. Well, if I solve for x, then I get the measure of angle N is 79 degrees. Same thing here. 51 plus 50 degrees is 101. If I add it with this missing angle measure, I should get 180 total degrees by the triangle sum theorem. And if I solve for that missing angle measure, I should get the angle T is equal to 79 degrees. And angles N and T must be congruent to each other. I also want to point out that there is no measurement of right here. So M, a little m and a little m, that doesn't appear here because we're not talking about how the numbers are equal. We're talking about how the actual angles themselves are the same size. So the angle N is congruent to the angle T. I could say the measure of angle N is equal to the measure of angle T, but we're not talking about that right now. We're talking about how the angles are congruent. So the angles are the same size. So let's apply the third angle theorem that we talked about right here. It says find the measure of angle C and the measure of angle F. So the measure of angle C equals something, the measure of angle F equals something. So I have two triangles. I have that angle A has an arc mark on it. I also see the angle D has an arc mark on it. So these two are congruent to each other. I see that angle B is a right angle and angle E is a right angle. Those two are congruent to each other. So the hypothesis of our third angle theorem is satisfied. That means that the conclusion is the third pair of angles are congruent. So that means that y squared, the measure of angle C, should be equal to 3y squared minus 72, which is the measure of angle F. So I can go ahead and set those two equal to each other. Y squared equals 3y squared minus 72. I can move my 3y squared over to the other side, so negative 2y squared equals negative 72. If I divide by 2 on both sides, I get y squared equals 36. And if I take the square root of both sides, I get y equals plus or minus 6. Now, since y equals plus or minus 6, and that's not what I was asked to find, I was asked to find the measure of angle C and the measure of angle F, I can go ahead and substitute 6 or negative 6 into this expression. 6 squared is 36 degrees, so that's the measure of angle C. And by the third angle theorem, we know that the measure of angle F is going to be the same as the measure of angle C, so this is also 36 degrees. Okay. Last problem. It says, pardon the hand sanitizer, it says in triangle WXY, the measure of angle X is 4 degrees less than twice the measure of angle W. The measure of angle Y is 24 degrees less than 3.5 times the measure of angle W. Find the measure of angle Y. So I'm going to need the measure of angle Y. That's my answer. Okay. So it looks very much like there is kind of a system of equations going on here. So I'm going to go ahead and create equations based on the sentences that are in my, my paragraph. So in the triangle, the measure of angle x is, so the measure of angle x is means equals in math. 4 less than, that means minus 4 at the end, twice the measure of angle w. So twice the measure of angle w. So there's one equation. Second equation comes from the second sentence. The measure of angle y is, measure of angle y is 24 less than, so that's minus 24 at the end, 3.5 times the measure of angle w. So 3.5 times the measure of angle w. Ooh, sorry, I had to squeeze that in. I also know by the triangle sum theorem that the measures of angles w, x, and y should all add to equal how many degrees? They should equal 180 degrees. So I can do substitution. I can take what equals the measure of angle x. I can put it in here. I can take what equals the measure of angle y. I can put it in here. Both of those expressions are in terms of w, and the measure of angle w is what remains in that large equation. So I'm going to go ahead and create my equation, and I should only have one variable in the equation. So the measure of angle x is actually 2 times the measure of angle w minus 4. I'm going to go ahead and put that in parentheses so that I know it's all one piece, plus the measure of angle y, which is 3.5, times the measure of angle w minus 24, plus the measure of angle w, and it should all equal 180 degrees by the triangle sum theorem. Something I do want to point out, though, is this 3.5 needs to be rewritten as an improper fraction. So I'm going to go ahead and do that. 2 times 3 is 6, plus 1 is 7. So this is really 7 halves, and I want to keep that in mind whenever I'm doing my combining like terms. So step 1 was to create the equation. Step 2, we need to solve, so we're going to have to combine. So 2 measures of angle w and 7 halves measures of angle w. If I add those together, 2 measures of angle w is really like 4 over 2 measures of angle w. So if I add everything together, here, here, and here, then I'll have 13 halves measures of angle w. So this is 4 over 2, this is 7 over 2, this right here is 2 over 2 measures of angle w. So 4 plus 7 is 11, plus 2 more is the 13 that you see here in the numerator. So all of this came from my knowledge of adding fractions and needing the common denominator of 2. I'm also going to put together my constants. Minus 4 and minus 28 is, or sorry, minus 4 and minus 24 is minus 28. If I add 28 to the other side, I have 13 halves times the measure of angle w equals 208. And if you recall from middle school or intermediate school, if you want to move this over, then you're going to multiply by the reciprocal. So the reciprocal of 13 over 2 is 2 over 13. The 2's cancel, the 13's cancel. The measure of angle w equals 208 times 2 over 13. So if you type that into a calculator, you're going to get 416 divided by 13, and you're going to get 32 degrees, which is kind of a miraculous answer. So step 3 was to solve. But they didn't ask for the measure of angle w, they asked for the measure of angle y. So you have to substitute. So the measure of angle Y equals, this was 7/2, times the measure of angle W, which is 32 degrees, minus 24. 32 over 2 is 16, and 16 times 7 is 112. If I subtract 24 from that, I'm going to get 88. So the measure of angle Y equals 88 degrees.